Hi, my name is Mingti Wang from China mainland, a senior student at SUNY Albany, majoring economics and actuarial science. This video is recorded as part of my application to the Master of Science program in Mathematics and Finance at New York University. It is noteworthy that I selected econometrics as a major course this semester and then learn a new tools data. This course benefited me greatly by giving me the opportunities to study the theories and methods in econometrics. Meanwhile, I luckily participated in a new research project of Professor Karen Ray Hunt, where our project software was used to study the data of Alaska forest fire. Based on the data provided by the client, I learned I used our project to analyze data and imported the results from our project into an Excel table for the further analysis. The goal of this research is finding the statistical model to test whether differences we observe from our original data are significant. We got our original data stored in several Excel tables from our client, which represent the proportion of fires in different regions. There's 4 different protection zones. C, F, M, L. We need to compare the probabilities of fires happens in these 4 zones. And so here C refers to the city areas and where have the best protections, and all the fires in C should be suppressed. So all the fires in L are usually untouched, so L will have the most fires. And we first use model y equal beta 0 C plus beta 1 F plus beta 2 M plus beta 3 L, and where y is a categorical variables corresponding to the percentage of every burns happens in these 4 regions C, F, M, L. And we need to test each beta is now equal to 0 by using our project. We run regressions, we get the coefficient values, and then we test the significance. In order to make further assumptions, we quantify the area burned into different burning levels in each region and see what it will look like. We then created some command and transferred the original data into different forms using Excel. We got all the data in form 0, 1, 2, 3. So here, 0 is equal to the no fire, 1 is equal to the area burned less than 1% and greater than 0. And 2 is equal to the area burned less than 5% and greater than 1%, and 3 is equal to the area burned is greater than 5%. So now we got all the data in 0, 1, 2, 3. And we made a bar graph based on all the new data we got here to see what it will look like. And at the end, we got the area burned in C is the least, F is the second least, M and L have the same level of area burning. So far, those are all the data that we observed. And then we will make a statistical model to see whether the difference we observe is significant or not. So by using dummy variable and ANOVA method, we created a statistical model. Y equal beta 0 plus beta 1 x1 plus beta 2 x2. x1 is equal to 1 in region F, M, L, 0 otherwise, and x2 equal to 1 in region M, L, and 0 otherwise. So we got mu C is less or equal than mu F is less or equal than mu M is equal to mu L, where we test each beta is greater than 0. So where is same as what we observed before and which is significant as well. At the beginning of the research, I didn't fully understand the methods teacher using into the project, which took me a while to master the entire application. As being an individual researcher, I felt the most important part was that I have to create and develop my own idea and then implement the idea by using all kinds of the materials I've learned before in the book or I was taught by the professor. This was really a new challenge for me, but I really enjoy the fun of doing research projects in the real world. I studied the degree of fire disasters, made a relatively accurate result in my report, which help my client to get the truth behind the data and make a better decision. This project not only helped me to get research experience, but also enhanced my interest toward data analysis and strengthened my resolution to use my knowledge to tackle practical problems. I obtained learning pleasure and research motivation during these processes. My first time to gain understanding of quantitative finance as I participated in two research projects in China. One is cause and benefit analysis of the effect of financial crisis rescue, and the other is theory and empirical research on financial resources, which have different focuses but are closely related. They all discuss issues about financial crisis. One is about lender of last resort, and the other is to give solutions on financial resources allocation. My job was to study models in these two researches. I constructed equations, analyzed, and identified problems using these models. With the help of MATLAB and eViews, I provide suggestions on solving these issues. Instead of settling for an understanding of the macroeconomics policies, I reviewed a lot of materials about commercial banks, investment banks, and all kinds of financial institutions. While I felt especially interested in the operation mechanism of these financial institutions, and was first time to understand the important role of a risk management department. I then paid closely attention to the position in this department. I chose the joint degree of economics and actuarial science out of my intrinsic love for mathematics and its application. I have dabbled in three major areas of quantitative finance in my undergraduate study. By reviewing my transcript, you may notice that the most courses were related to mathematics and statistics, including calculus for several variables, probability for statistics, continuous probabilities, mathematical statistics, applied statistics, and applied stochastic processes. Besides, I also took courses to hone my finance skills as financial economics and familiarize myself with capital asset pricing models, options, futures, term structure interest rate, and interest rate forecasting. As for the computer contents, I also took two courses in computer science and thereby mastered the programming skills in C++ and Java. I think my current weakness is that I need more finance skills, including theories, models, and mechanism of financial processes. That's one reason why I want to apply to a master's degree in quantitative finance. During the college period, I gradually established my own unique mental model for solving problems using mathematical modeling and kept modifying details. I'm convinced that it is this mental model that allows me to do the best I can in the field of financial mathematics and to keep making progress in my career. My objective is to enter your master program, and I expect to engage in mathematical modeling in the risk control department of a financial institution after graduation. From my point of view, my job was quite similar to what was required of modeling professionals by quantitative finance. Meanwhile, after some in-depth research of financial crisis on a macro side, I grew extremely interested of risk control on a macro side. I aim to do mathematical modeling in the risk control department of a financial institution, which is the ideal prospective career for me so far, if I can make use of my advantage in mathematical modeling. That is another reason why I choose quantitative finance.